Okay, so today's lesson is on finding the inverse of a radical function and proving inverses by composition. So we're going to start off with function t. We notice it's a square root function. So we're going to go ahead and start by switching the x and the y. So when you're finding the inverse, remember to switch x and y. So t of x is your y, so that's going to become your x. X is going to become your y. Nothing else changes. Okay, second step, we're going to solve this new equation for y. So to solve for y, we need to undo the operations. Remember, to undo the operations, we have to start with undoing, adding, and subtracting first.
Good morning. Science achieves avid and compliance. Please report to the teacher station at this time. Science achieves avid and compliance. Please report to the teacher station at this time. Thank you.
Then we undo any multiplying and dividing, and there's nothing being multiplied on the front, so we can move on. We're going to undo the exponent. Remember that the square root is the 1/2 power. Remember that the square root is the 1/2 power. It's equivalent form. So we're going to square both sides. This is a group over here, so we need to put some grouping symbols on it and square it. Okay? You don't have to work this out. You can just leave it like this. And now we're inside the grouping symbol. In this case, the grouping symbol was a radical. So inside, we're going to undo the +3. I'm going to go ahead and turn this around. I'm going to put y over here, which in this case represented t of x. So this is the inverse of t of x. So we're going to use this symbol here to represent inverse. This is the inverse of function t. So as you can see, the inverse of a square root function is a quadratic. Now, let's take a look at the graph for these. I'm going to pause the video for a moment. Okay, so let's go ahead and start by graphing the original function. So to get to our starting point from the origin, we would need to go 3 units to the left and 1 unit up. So 3 to the left and 1 unit up. Okay, and then we're going to follow the square root pattern for the parent. I asked you to memorize that. So 0, 0, 1, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. Alright, so that is t of x. Alright, now graphing the quadratic. Remember the quadratic, we start at the vertex, and we're going to translate 1 to the right and 3 down. Alright, so that's going to be our vertex. Now going to the right here, we're going to, the a value is 1, so remember the pattern for quadratic. 1, 1, 2, 4, 1, 2, 3, 9. All right. So here is the inverse. Notice I did not do the other side. Okay? We're only going to do the inverse for this part of the original function, and this is why we need to restrict the domain. because we're only going to count half of the parabola. So the domain restriction here for the inverse is going to be from x is greater than or equal to 1. For the range, it's going to be y is greater than or equal to -3. And that is your domain restriction for this inverse function. All right, now let's move on to the second part. This is kind of a review from yesterday's video. Now we're going to prove that t of x and the inverse t of x, we're going to prove that they're indeed inverses of each other. So to prove it, we're going to use composition. Now we learned composition first semester, but we'll review it right now. We're going to go ahead and we're going to start by taking t of x and plugging in the inverse of t of x. So the inverse t of x, we're going to input that into the original function. And the outcome that we want to have is x. Remember, x is because that is the line of symmetry between an original function and its inverse, as you can see on the graph. The line y equals x, that is your axis of symmetry. Okay, so let's go ahead and plug this in. So starting off with our original function, we have the square root, and we're going to input in the inverse in for x. So we're going to input this in for x. Okay, so this function just went in for x. Now we have a +3. Notice it's still under the radical. Notice I put a little tail there. That 3 is still under the radical, and the +1 goes on the outside. Now I apologize, I was not on the right part of the sheet just then. So here's your inverse, and it got plugged in for x. Okay, so let's simplify this and see if we end up with x. So first thing we're going to do, we're going to subtract and add the 3. Which cancels out. Okay, and then the square and the square root cancel each other out. And then the -1 and the +1 cancel each other out, and that leaves us with x. So now we have proven, at least this way, that these are inverses. Now the second way we want to prove this is we want to plug in the original function into the inverse and see if that comes out to be x as well. So this is what I want you to do. I want you to do the other composition and see and simplify it and see if it comes out to be x. I hope you all are having a good evening, and I'll see you in class tomorrow.